Hi guys, I'm going to be explaining parts 3 and 3.5 for our mechanics exam for the physics final. So let's start with finding the center of mass of a uniform lamina, y equals f of x, this lamina, this line, basically. And it's bounded by the x-axis and the lines x1 equal a and x2 equal b. Now to find the center of mass, which is this point G, you will need to find x bar and y bar. So the formula for x bar is integral. You're gonna have to integrate. It's integral from a to b of x times y dx over integral from a to b of y dx. Okay. Yeah, so you just substitute. You're gonna have to find the y is basically f of x here, and you just substitute and then integrate. And to find y bar, it's gonna be integral from a to b of y squared dx over integral from a to b of 2y dx. So yeah, same thing, you just substitute and you square f of x over 2 times f of x. So yeah, you just substitute, and that's basically how you find it. Now, another thing they might ask you for is the center of mass of a lamina bounded by the graph y equals fx, the x-axis and the lines x equal a and x equal b, but this time it's being rotated around the y-axis, about the x-axis, sorry. It's being rotated about the x-axis. So to find this, y bar is going to be 0 because g is here. So y bar is going to be 0, and x bar, you're going to have to use this formula. The integral from a to b of xy squared dx over the integral from a to b of y squared dx. Now, you just substitute, you square f of x and you substitute. And sometimes they might tell you that it's being rotated about the y-axis. So basically it's vertical, not horizontal. In this case, x bar would be 0, and you would use this same formula, but in terms of y. This same formula, so it becomes dy, not dx. You would integrate in terms of dy if they told you it's being rotated about the y-axis. Okay? Now, they might also ask you about the center of mass of a lamina. I mean, not a lamina, sorry. At the center of mass of a uniform wire in the form of an arc of a circle, radius r. So this is the radius r, this dotted line. And it subtends angle 2 alpha, this angle, 2 alpha, at the center, okay? So to find this center of mass, G, is x bar, you're gonna have to use the formula r sine alpha over alpha. But you have to keep in mind that it subtends angle 2 alpha. So you're going to divide the angle by 2 before you use this formula, and this is for when they're telling you that it's a wire. When you have a wire in the form of an arc, the shape of an arc. Okay? Now, sometimes it might not be a wire, it might be a lamina. They would tell you that find the center of mass of a uniform lamina in the form of a sector of a circle of radius r, subtending angle 2 alpha from the center, at the center. So this time, it will be, you change the formula, it becomes 2 over 3 r sine alpha over alpha, instead of just r sine alpha over alpha. But you also need to be careful that it subtends angle 2 alpha, so you're gonna have to divide the angle by half. You guys divide the angle by 2, so that you can get just alpha. And you substitute, and that's how you get x bar. Let's continue with the formulas of finding center of mass. So they might ask you to find the center of mass of a uniform solid cone. You're gonna need to know the formula. That is, if you're starting from here, the top, from the vertex, OG, if you're starting from, let me use another color. If you're starting from OG, from O, and you're trying to find this, you're going to be starting from the vertex, so OG would be 3 over 4 times the height. But if you're trying to find it from the base, it depends which way the cone is drawn. So you need to know both formulas. But yeah, it's just going to be 3 over 4, h minus 3 over 4h, which is 1 over 4h, because this whole thing is h. So if this is 3 over 4h, and this is I drew it it should be further here. If this is 3 over 4h, then this is going to be 1 over 4h. I didn't really draw it exactly. Yeah. So you need to know that this is x, this would be x bar, this or this, depending on how they draw it. And then m, to find the mass of a solid cone would be rho times v, the volume, because it's solid. So v would be pi over 3r squared h, and then you just multiply, and that's how you find the mass. Now for the uniform solid hemisphere, same thing. You have two formulas if you're finding it from the top or from the base. If you're finding it from the top, it would be 5 over 8r radius. And if you're finding it from the base, it would be 3 over 8 times the radius, because this whole thing is the radius. So you just if you know one, you know the other, because the other would be, if you know this one, 5 over 8r, you just do r minus 5 over 8r, and it would be 3 over 8r. But you can just memorize whatever you want. Yeah. And for the mass, this time, because, yeah, the mass is the same, it's also rho v. So v would be 2 over 3 pi r cubed, and then times rho, and that's how you find the mass. And then for a hemispherical shell, which is basically the same thing but hollow from the inside, the center of mass is half r. So whether you're finding it from the top or from the base, it's going to be half r. It's the same thing. For a cylinder, it's also half the height, not r, the height. So if this whole thing is the height, this is half r, and this is half the height, and this is half the height. So it doesn't really matter which side you're taking it from. And for the mass of the cylinder, there's two cases. It could be a hollow cylinder or it could be a solid cylinder. If it's a hollow cylinder, then the mass is sigma area, and the area is 2 pi rh. And if it's a solid cylinder, then the mass is rho v, and v is pi r squared over h. So you need to know both. Yeah, so when they're telling you that they're adding, for example, when they're telling you that they're doing, like if you have a graph like this, an area like this, if you have, let's say here, this is a cone, this is a solid cone with a cylinder, a solid cone with a cylinder, and they're asking you to find, this is the x-axis supposed to be in the middle. I didn't draw it properly, but it's okay, just imagine that this is in the middle. And they're asking you to find g. So you would do x bar m1 plus x bar m2 plus over m1 plus m2, right? And then that's the formula for finding. So let's say g was here. We don't actually know where it is. If it were here and this is O, OG would be this. So you need to find x bar of the cone. So because this is part 1 and this is part 2. So x1, x2. x1 would be the center of mass of the solid cone. So you go back to your formula, which was here. You're starting from O and you're taking until g, it will be 3 over 4h. So x is 3 over 4h. And m would be rho v. So you also go back to your formula, which is rho pi over 3r squared h. And you substitute and you find that. And for this one, it's a cylinder. So x bar is going to be half the height, this height. They're going to give you a height, and here they would give you like the radius from here to here, and the height from here to here. This would be given, and this radius would be the same as this radius. So yeah, and then so x bar for this one would be half the height, and the mass depends if it's hollow or solid. Let's say it's solid, it would be rho pi r squared h, because it's rho v, over the sum of the two masses. Let's say they told you that you have two cylinders, this one and then a smaller one inside, and you're subtracting them. You're removing the small cylinder from inside the bigger cylinder, and you're trying to find the new center of mass. In this case, the new center of mass would be x1 m1 minus x2 m2 over m1 minus m2. So you need to be careful whether they're adding the two shapes or removing one from the other, because it changes the sign. The formula is the same, but the sign changes, either plus or minus. Okay, and for part 3.5, when it's at equilibrium, you need to know, well, you don't actually need to know this, it's just a trick to make you like get the answer faster. Tan alpha equals to r, the radius of the base, over the distance from the base to g. So let's see how you can use this formula. We'll find an example. One second. So if they give you something like this plane, a rough plane that's inclined at angle theta, and a cone, and they said that the angle, this is the cone, this is your cone, and this is G, center of mass, and this is O, and GO and OG would be 1 over 4h, because when you go back to the formula, in the solid cone, if you're going from the base to G, it would be 1 over 4 times the height. Okay, and this is the radius, right? This would be the radius, or okay. Now they're telling you that theta, the angle of inclination, keeps increasing, and they want you to find at what angle would this cone be just about to topple. So like at what angle would it be on the edge of falling off and toppling. So to find this, you need to draw the weight. When it's just about to topple, you need to know that the weight passes through the vertex here. So this would be W. When it's just about to topple, this is how the weight looks like. So to find theta, you need to also keep in mind that this angle is equal to theta. You need to know that this angle here is theta. It's equal to this. These two are the same. So, and this is a right angle. This is 90. So to find theta, let's say they told you the height is 6a and the radius is a. Okay, so let's find OG. OG would be 6a over 4, which is 3a over 2. Okay, and they told you to find theta when it's about to topple. So tan theta, because it's easier to find tan theta and then do shift tan. Tan theta would be opposite over adjacent. The opposite here is r, which is a, over the adjacent, which is this OG, which is 3a over 2. So basically this formula again, tan theta is r base over the distance between the base and g. That's basically it. You don't have to use this formula, you can just use your logic. And then it's gonna be 2/3. So you do shift tan and you find the angle. Yeah, that's it. That's how you find it when it's about to topple. That's basically what 3.5. Yeah, so make sure you solve the basic questions related to these questions, and good luck in your exam. Bye.